Hi 607 and 608. Earlier this week we looked at composite figures and they were irregular shapes that were made up of shapes that we recognize like rectangles, triangles, or squares. So today we're going to be calculating the area of composite figures. So step one is to identify the shapes in the composite figure. Step two is to identify the area formulas for the shapes in the composite figure. Step three is to use the area formulas to calculate the area of each shape. And step four is to add the areas of the component shapes together and label your answer. So here we have an example of a composite figure. Step one is to identify the shapes in the composite figure. I can't believe only one kid showed up for school today. I'm gonna have to call Mr. Warnock. What shapes do you see in this composite figure?
I see a rectangle and a triangle.
So he says that we can see a rectangle and a triangle in this composite figure. Mikey is correct. Here, this bottom portion, that I'm going to shade in blue, would be a rectangle. I know it's a rectangle because it has two pairs of parallel sides. The opposite sides are equal and the corners are right angles. Up here, this top portion is a triangle. I'm shading this in green. So now that we've identified the shapes, we now need to identify the area formulas for the shapes. So we have, for step one, a rectangle and triangle. Step two, identify the area formulas for the shapes in the composite figure. For a rectangle, to find the area, I need to multiply the length times the width. So a long side multiplied by a short side. So for step two, the formula for the rectangle would be length times width. For a triangle, I need to multiply the base times the height and divide by 2. So the base is the bottom of the rectangle and the height is a straight line either drawn next to the triangle or sometimes you'll see it drawn through the triangle. So for the triangle I have to do base times height divided by 2. Step 3, use the area formulas to calculate the area of each shape. So first I'm going to calculate the area of the rectangle for step 3, where I'm using the area formulas. So instead of writing length times width, I'm going to substitute in the values that I know. So I'm going to put area is equal to 8 times 6. Class, does anyone know what 8 times 6 equals? Oh, good, Mikey again.
So 6 times 8 equals 48.
Oh, jazz hands. He is correct. 6 times 8 would be 48, and because it's area, I label it as the units, which is feet in this case, squared. Now I need to substitute in what I know for the triangle. So I see the height is labeled here as 3 feet. So I can write A is equal to something times 3 divided by 2. This is the base measurement, which I don't see a measurement here. But I do know this bottom piece is 8 feet, which means if this was an actual perfect rectangle, this whole thing up here would also be equal to 8 feet. This little section here is labeled as 2. So this piece of the side is 2 feet, and this piece of the top side is also 2 feet. So I'm trying to figure out just this section. So 2 feet plus a number I don't know, plus another 2 feet has to equal to 8 feet. 2 plus 2 plus what number would equal 8? Oh, he's checking back in his notes.
It would equal 4 feet.
Excellent. 2 plus 2 plus 4 does equal 8 feet. So here I'm gonna write 4, and now I'm going to solve this. So 4 times 3 is equal to 12. Does anybody know what 12 divided by 2 is? Mikey.
It equals 6.
Excellent. So the area of my triangle is 6 feet squared. Step 4, add the areas of the component shapes together and label your answer. So now I'm here at step 4, where I now need to add 48 plus 6. Would anyone like to come to the board and add this? Come on down, Mike.
So 48 plus 6, 8 plus 6 equals 14. So we put a 1 over here. It equals 5 over here, and then there's a 4 over here.
Excellent. So our total area equals 54 feet squared. Please let us know if you guys have any questions. We miss you.